Hello, everyone, and welcome to the Siemens webcast series focusing on key features and functions of the Sinumerik CNC Control. I am your host, Chris Pollock, and today we're going to get a chance to dig into some of the nuances of 5-axis CNC setup. But before we get into the core material, I did want to take a couple minutes and just give you some additional information you might find helpful. As well, I'd like to introduce our latest team in the Siemens family, the team we're calling the Technology Application Team. So for those of you that know me and are familiar with me, you probably knew that I was managing a great team of guys called the User Support Team. And that team was made up with regional technicians, regional account managers, as well as product specialists. So to really better serve the market space and to aid end customers and distribution channels and OEMs a little bit more, we decided to split the product specialist team out, and that is what we're calling our technical application team. So I have the pleasure and the privilege to introduce you to my small but very skilled team of specialists. Myself, I'm still based in the New York area, and I'm managing and heading up our virtual technical application center. We have Dan Struble, my CNC specialist, based out of our decks in Elk Grove Village, Illinois, and he's managing our physical technical application center, as well as working on all kinds of material and things CNC focused. And then we have Brian Baumgartner. He's our system engineer. And Brian Baumgartner is here to support us when we need to get even deeper into the control. So take a minute and welcome this new team. I'm sure you're going to get a chance to engage with us moving forward. You know, the real idea here is we can kind of take what we were doing originally with, developing videos and webinars like you're in today and all kinds of online content, and we can really amp that up. So we're going to be focusing on a lot more material generation and resources for you. So with that being said, if you are new to the program and you're looking for areas where you can, reach out and find information specific to the Sinumerik Control, I would say your first stop should always be our CNC for You website. So there's the direct link, the usa.siemens.com/CNC for You. Pretty much all things end user centric or operation and programming centric can be found or linked from this page to other resources. So certainly all of the webinars, we promote them here. You can get to our past webinars on this page. There's all kinds of training classes you can take advantage of if you click the training link. If you go over to the training link, you can see we have both in-person, we have online instructor-led classes, all kinds of different materials. So head over to CNC for You, check it out. There's a lot of resources here for you. As well, we have our YouTube channel. So if you haven't been on it, you want to get to the Mr. CNC YouTube channel. We use this as our core library. So all of our material, including this video, will end up being posted on the Mr. CNC channel. But we also generate a lot of content that is specifically only hosted on this channel. We do a YouTube live series. We do a lot of little promos and how-to videos. So make your way over, check it out. If you like it, please remember to like it, share it, and most importantly, subscribe. It's that kind of engagement with you guys that allows us to show to management that this is a very successful program and they can continue funding it and we can grow. And that honestly, that's what led us to be able to break out and have a focused team now on this material. So keep it coming, keep on working with us, and certainly go into the comments and let us know any kind of interest you have. Maybe there's other information you want us to produce. So let us know that in the comments and we'll try to get it into the series or the swing. Okay, and then the last program we have, which is an exciting program we call our Virtual Product Expert Program, or acronym is VPE. This is a way for you guys to gain access to product specialists within the Siemens realm and effectively book an hour session to pick their brain. So Certainly my team manages it. Brian Baumgartner under my team is managing this program. But if it's topics that are outside of our expertise, we certainly can also reach out to others within the organization and bring them in. So any and all questions you have regarding Sinumeric product, this is a great path for pre-sale support. So you salesmen out there, if you have a customer that's on the fence or just wants to learn a little more about Sinumeric, bring us in. We'd be happy to do a nice product demo for them. For those of you that are maybe commissioning engineer or high-level technicians, you need to get into the bowels of the control. It works for that, great for that as well. So reach out to us. Go to this link. You can request a session, and then we'll reach out to you, find a good time slot, and book it. So without further ado, I'd like to welcome Dan Struble, my CNC product specialist, also better known as Mr. 5X. So Dan, welcome to the program.
Thanks for having me. I appreciate it.
Absolutely. So Dan is going to be our presenter today. He is an expert in 5-axis. If you've never seen Dan run a 5-axis machine, you need to experience it because he comes with a wealth of knowledge. He's been a great addition to the team. You've been with us now, what, 2 years now, I think, Dan? Something like that?
Coming on 2 years, yes.
Coming on 2 years. 2 good years, I hope. So
that's been great.
With that, let me switch it over to you, Dan. Dan's going to drive this event. So you guys should start to see his screen here as it's transitioning. I will say before I completely give it over to Dan, there is a Q&A panel as well as a chat. So as questions come up, throw them in there. We will have a reserved Q&A period at the end of the event. If I do see a point during the topic where maybe I can throw a question and I might try to do that as well, but we will definitely try to address them all by the end. So without further ado, Dan, it is yours.
Thanks, Chris. I appreciate it. Mr. CNC, Chris Pollock, thanks for announcing the first half of this webinar, and I appreciate the introduction. We're going to get into some 5-axis CNC setup. So the webinar's title was Mastering 5-axis CNC Setup with Siemens Sinumerik Control. So that's what we're going to do today. And we're going to kind of talk about some nifty tricks that we have on our control that allows you to set up your 5-axis machine relatively quickly. With that, just some kind of overview of what we're going to kind of attack in this webinar is the basic information of 5-axis machining. We're going to talk a little bit about tooling and work holding in a simple 5-axis setup. We're going to go through and actually do it on a virtual machine here on the PC. And then we're going to talk a little bit about some advanced 5-axis setup, as well as do a live demonstration on the PC in a virtual machine of setting up the advanced tooling and work holding here on my PC right now. So just to kind of get into it, what is 5-axis and what are some of the 5-axis machines that we get to see throughout the world and the different types? So as we kind of move over, we kind of have head starting from the left going to the right, and that's where the rotaries are actually in the head and the spindle is all in the head. So we have 2 different types. We have, an AC or BC, and then we have mixed kinematics where we actually have a head and a table with it. So there's also a rotary in the table, and then there's a table kinematics. The machine that we'll be on today will be a table. So a couple different kind of kinematic setups to do 5-axis. They all kind of have their unique and subjective applications to do 5-axis. So that is, kind of picking which one kind of fits your part and the way that you're going to need to machine it. Obviously, if you're bigger parts, you're going to kind of lean more towards a head kinematics. If you're, maybe doing some turning and maybe doing some kind of big part that's turning, you might lean towards a mixed kinematic with a head and a table. And then more traditionally, our table kinematics that come in a variety different kind of setups. Maybe they might be able to do turning, they might be able to be mutated table. So there's a bunch of different ways you can kind of set these machines up, with the kinematics. So the basics of 5-axis kind of break into two distinct things, and we're going to look at both of these. I'm actually going to run a program in the advanced setup as well as the simple setup of doing 3+2 machining and dynamic machining, 5-axis machining. So that was where you're going to have all 5-axis moving at one time. So that's kind of really kind of the gist of 5-axis. And 3+2, I'd say 80% of your machining done in 5-axis is 3+2. So we're just going to position the machine, and then we're going to do our machining, whether it be drilling, tapping, milling, surfacing, whatever it may be. We're just going to position to a plane, machine it, position to a plane, machine it. And then there's full dynamic 5-axis where we're moving all the 5-axis at one single line of code, and that's to do maybe a surface or do some type of airfoil or do some type of aerospace part that requires all the axes to move it at one time. So this is a really kind of distinction of what you may be doing in 5-axis. With us, that we're definitely going to really kind of dive into today is why Siemens makes it a lot easier to set up your 5-axis part. We have a couple different things that really are crucial, in my opinion, when you're setting up a simple 5-axis part and making that really quickly, make it your setup quicker, as well as when you get to some advanced work holding where you want to set that up and not really have to bring out your indicator or understand where your angles are to get this part set up, or your work offset set up on each one of your parts on an advanced setup like a tombstone or a pyramid. So we're going to talk about that. So getting into it, if we're going to look at a part, we're going to look at a simple part, and we're going to use that for simple 5-axis setup, as well as we're going to use that same exact part, but we're going to hold it in a pyramid for the advanced work holding when we get to it. So here's a simple part. We just got a little 5-axis path on the top of this cube, and around it we have some pockets. So we have 5 sides that we're going to machine, and we're going to utilize that in a 3+2 manner, plus some 5-axis at the top of the part. So 5-axis work holding. Here's some kind of distinctions between what we've kind of had in the past and what's kind of emerged over the years for 5-axis. Is we used to have, just a fixed vise, what they would call a fixed vise. And what that meant is that there was one of the jaws that was on the vise that was fixed. It would not move. So they would call that, the fixed jaw, and this jaw would be stationary and it would not move. And then there would be one that would be dynamic that would actually move and clamp your part. So some benefits to that is you're always clamping on one edge. You're not, you can set your one edge to the fixed vise and it's always going to be there, which works perfect when you are on a 3-axis machine. When we went to 5-axis, we really wanted to make sure that that part was in the center of the table. And this used to be the kind of the way that you would set up a 5-axis machine. With SINUMERIK, what we've developed over the years is we don't have to be in the center of the machine. So that's one of the biggest things. And this is where kind of the center vise kind of came up of. It came up where both jaws move now and they clamp the part in the center of it. So now your work offset's in the center of the part. And one of the nice things about this is because we're clamping and both jaws are moving together to the center of the part, the vices ended up being kind of really small. So this really was an advantage so that you can start to have a little bit smaller vices on your table. And then also because of 5-axis needing to be in the center of it, as well as being off the table, there was an easier way to build these vices off being small. You were able to build it off the table to give yourself clearances. And what I mean by that is there's usually, when we look at a 5-axis machine, we really want to look at what the kinematic setup is and then getting the part off the table so that the head doesn't collide with the table when it gets rotated up at 90 degrees or past 90 degrees, 120 degrees, that we have enough clearance to clear the spindle. So we'll get into that when we actually start to set this part up, and I'll mention it again about how we actually set this up and we then know for each one of our setups that we should at least be, 5 inches, or we should at least be 6 inches off the table, because that's how far it is from the edge of our spindle head to the center of our spindle. That way it gives us an ability to make sure that we're always going to clear the table. We're always going to have a nice safe setup. Excuse me. Along with work holding is usually tool holders. So usually in a simple 5-axis part using an ER collet, there's a wide range of documentation and a wide range of clamping for ER collets. It's super compatible to machine. So this is, you're always going to find an ER collet in every shop. So this is, commonly what you'd use on an easy setup. You got a 1/2-inch end mill, you put the 1/2-inch end mill in there, and you got a 1/2-inch collet, so it's really nice. And then also too, a good one for roughing, and a kind of a simple tool holder that's used in 5-axis is a side locking end mill holder, so then that you can just basically lock it into a notch on an end mill and use it for roughing. So this is kind of nice, as it won't pull out. There's going to be some better tool holders that we'll talk about when we go to the advanced, but this is pretty much what you kind of see in the basic 5-axis, a simple part. Overarching on a simple setup on a 5-axis as well as an advanced, there's something that's really crucial that the point needs to be drove home, that this is really kind of crucial when it comes into full 5-axis and 3+2 is transitioning to this thing and this concept of positive tool length. And what positive tool length is it gives the ability to set your tool to the gauge line of that tool. So what we're seeing here on the screen here is we see an end mill in a collet holder, and that end mill is 539, right? And so that this tool assembly is going to be 539 in any machine anywhere in the world. It's going to be 539. So we're just going to the tool gauge line, and that is what we're going to actually put in the tool offset for this tool. The nice thing about this is now we know if we take this tool to another machine that it's going to be 539, but this is kind of crucial so that the machine kind of knows where that tip of that tool is. So that's really kind of crucial. It helps with tool management, as well as helps in setup, so you can offload your tools to a presetter and set everything with a presetter. You can use, in the machine, you can use it. And let's say your tool laser or your tool probe goes down, you can set your tools up manually really well, easily in the machine. So this kind of makes life a lot easier. We're not beholden to some point that was set on some fixture and some big negative number. So this is really kind of really nice. So this is a really good thing that I really kind of stress, and I'm definitely going to have more on this as I start to do more videos, because I think this is a really kind of nice topic to kind of talk about, because it really kind of differentiates when you make that kind of jump into 5-axis. So what we're going to use today to set up both the simple 5-axis setup as well as the advanced 5-axis is a cycle called align edge, and we find that by hitting jog, measure, and then we'll find our align edge, and we're gonna choose the align edge here, and we're gonna set 2 points to actually set the rotation of our part. So this is kind of a really nice feature. What this means is there's no more pulling out your indicator and indicating your part in or indicating your vise in. Just lock your vise down with 4 bolts, 4 T-nuts, and put your part in the fixture, clamp it down with a torque wrench, and bring out your probe, hit 2 points, set your rotation in your C-axis, and then you're off to the races and setting your X, Y, Z. And now you can hit cycle start, and you can start with your 5-axis part. So we're going to actually get into that. So simple 5-axis. So the first things first is we got to get work holding, and we got to get our tooling set up. So we're going to use a piece of software called My Virtual Machine. My Virtual Machine is going to be a real live machine that's going to be brought into the PC, and it's going to be exactly the same. So the probing is going to be the same. The offsets are going to be the same. The MDs are going to be the same. So it's definitely going to be the same as what we see here. So the nice thing here is we can actually do probing. So we're going to jump into that. So here's my 5-axis machine. We have a BC kinematic style machine, and we first need to think about how we're going to actually machine this part. So we had our cube. We're probably going to need an end mill, so we can start to build that up. So the nice thing in here is this piece of software accepts step files. So from my NX session, I just exported my tool out in a step, and now I can bring that in and start to build that tool. So the first things first is I'm going to set that up in my work offset, and I'm going to build my tool and then touch my tools off. So first thing is I'm going to come down and I'm going to build a tool, right? So I'm going to say an end mill under work offsets, and I'm going to call this 12 millimeter end mill 1, right? And one of the things that I need to know is I need to fill out the data. So I know that my gauge line for this tool was 170, and I know that my half of 12 is 6. So then once I get that in here, I can load it into my tool. So how this would happen in the real life is once I created it outside the magazine, I would hit load, and it would tell me, okay, you're going to load it in magazine 1 in location in pot 25. So once I get done with that, now I know in pot 25, here's my end mill, right? And when I want to start to build that in the 3D environment, all I need to do is hit minimize, and I have this tool here defined. So now I can go and find that tool. So I have tool end mill 1. I can do to this detail protection. And once I get to detail protection, I have the end mill that I created on the control side, but I have not created anything in here for the 3D model. So here I just import tool assembly, and then I have my HSK ER32 that I picked with my 12 millimeter that I took out of my CAM and CAD system. I open it up, and it'll bring up a window that will have my tool in there. And then I can start to choose, do I want the end mill? Do I want my shank? And how I start building this tool up in the software. So this is kind of really nice. So the first things first, I'm going to set my holder. So I have my holder here, right? And so this is my holder. I say select this as my holder. So this is this object. I say select it as this holder, right? And then I'm going to uncheck the holder and do my cutter. And I'm going to say select that as my cutter. And now I have my tool holder built. I say import, and there's my tool. Okay. Once I have that, I can hit save changes. And now I have save changes. There's my tool. Okay. And one of the things is we know what the gauge is from our CAM system because it's the perfect world, but in the machine, we're going to definitely want to touch this off when it comes in the machine, right? So we can do that relatively easy. We're going to come to machine and jog, and we're going to jog that into the machine. So right now there's nothing in the spindle, so we need to get that tool in the spindle. So we're going to come to a page under jog. TSM, what TSM stands for is tool spindle M code. So if you want to do any type of tool changes, it's under this page. You want to turn your spindle on to any RPM, it's under this page, as well as any M code that you want to turn on. And also under this page, you can set work offsets. So this is kind of really nice. So you can kind of bring your tools in and out there. You don't have to remember any offsets. The offsets come with it. So right here, we're going to go select that tool. So on our vertical soft keys here, we have select tool. It pops up a window, and then I go find that tool. This is the tool we created. We say okay to that, hit cycle start, and once I hit cycle start, it's going to bring the tool into the spindle. There it is. And now we want to measure that tool, right? So we have a tool, and we want to measure auto, measure length auto. So I'm going to measure the length, and all I need to do is hit cycle start. So I hit cycle start. She's going to go over and touch the tool probe and set our probe. So obviously we look at our offset here in this box. This is the offset for that tool. So there was a little bit of discrepancy on that to the perfect world when it come over. So this is why we would set it up in the machine, right? Next, we want to set our work holding up in our part, right? So we have that cube part. We want to machine that and do all that. So we need to set that up. So we can come into our minimize again and go into our library, and we have this new setup button. And in that new setup button, we're going to create a new setup. We're going to need to get our work holding. We're going to need to get our vise in there as well as our workpiece, right? So I've already put that in here. And once again, you can create either an STL or a step of your work holding. So I created STL of my work material. So my 3x3 cubed, there it comes in, right? And I also created an STL of my work holding. Okay. And then I can call this, my setup, right? Like block _1, right? So I have my setup now. Once I save that, and I come into, oh, sorry, that component already exists. So let's make a new name. One. Oh, sorry. Had the same name. Hmm. Sorry. There we go. She's happy now. Just had the same names of one of those work pieces that I was working in here earlier. So now when I go back to the machine, I have this setup button, right? And now I can pick my setup, right? So I bring my setup in. As soon as I hit double click, she goes on the table. I can go back into machine. And now I have my fixture in my workpiece. If we take some of the covers off this machine so we can start to see this a little better. One of the things that you can kind of see from this simple setup of this 5-axis is she's quite high off the table. And there's a reason for that. So the reason behind that is really depending on the kinematic setup, whether you'd be a table or head or mixed head and table, is really kind of a couple of distinctions. Is one, if you're on a table, the key here is if you have a BC, you're going to look at the dimension from the side of your spindle, your Z axis, and to the center of that. And that's how far off you're going to want to be from the table. And the reason being is if we start to say we want to move B at 90, right? And we hit cycle start. Once that is off the table, what we want to see is if we move X over, right? We want to have the spindle be far enough away from the table when we come down. So this is the key. So usually the distance from here, from this edge to the center of the spindle, is a good number to be away from that table. So obviously I have some great distance there. I'm going to be safe. If I even needed to get to some negative numbers, I probably potentially can, because if I said now here, if I wanted to be like this, I definitely am going to be safe as I come down and try to machine something on this lower end of this part. So the key here is understanding that for a BC, you're going to look at the spindle from the right side and go to the center, and whatever that distance measures is what you're going to want to keep off the table. And if you keep to that rule of thumb, usually it's somewhere between 5 to 7 inches. So somewhere in that range is going to be a good number, staying away from the table and getting that built up, that fixture out there. So that's what I've done here. So now I can actually come and start to set my part up, because I haven't set my work offset. I haven't set anything. I haven't set anything up, so now I got to do that. So the first things first is knowing which fixture offset you're going to use. For this part, I'm going to use G57. This is what I've wanted to use, so that's what I'm going to use. So I hit cycle start on my B, get her square again. And for a simple setup like this, like I said before, you don't have to bring out your indicator and run it along this edge of this jaw or run it along the base. You don't have to do that. If you wanted to get this set up really quickly, lock this base down, stack up this fixture and lock them down, put your workpiece inside there and start to bring out the probe. And that's exactly what I'm going to do here. So the first things first, on a simple 5-axis setup like this, I'm going to bring out the probe. So again, I'm going to go to TSM. I'm going to select my probe in my tool page and I'm going to hit cycle start. She's going to go over and grab the probe. So there's my probe and the spindle. And now I'm going to set this part up not using an indicator. I haven't brought out the indicator, and everything that I'm doing here can happen on the real life machine. So I'm going to move over to my part, move over in X. Move down in Z. Oh, I got too close to it. So there's a little bit of a collision there. So I got too close to my probe. So here, now I can move over in Y. And my kind of rule of thumb here is a couple things, because I want to know where I'm at in space. I'm going to just get my Z height here. And that's kind of a quick thing to get my Z height, and then I can go into starting to set my workpiece up. So here, I'm going to come to measure workpiece. So kind of workflow is get my tool in the spindle. I can either set a work offset really quickly, manually, and then also now I can measure my workpiece. So this is kind of like a workflow. We go step by step by step. Now we're into measure workpiece. We're going to hit Z height. So cycle start. And the reason why I do that is now I know that I'm 3 millimeters above the part. Okay, so I'm a little bit above the part. So now when I start to align my edge and align my C, I know now that I can get my part aligned up and I'm not going to crash into my part because I know that I'm right above it, 3 millimeters. So if I hit minus here, now I know I'm minus, but I'm too close in Y, so I want to come off and part a little bit. So that's kind of what I do first. I come and hit a Z hit first, and then I know that, okay, now I know I'm 10 millimeters below the part, and that's enough to hit a 2-point hit on my stylus, because my stylus is 6 millimeters. Once I get it positioned a little bit on the X side, I'm going to go back into measure workpiece, and I'm going to use this align edge function. And what the align edge function is it gives the ability to rotate my part or rotate my physical C to set this part up. And I'm going to choose coordinate rotation. And there's a reason that I'm going to choose that is because I'm going to rotate my coordinate and it's going to go into my work offset. So as soon as I hit 2 points, again, we're in the perfect world, so we might not see a huge change here. So I hit my first point and it saves it. And then I'm going to come over in X and I'm going to hit cycle start again. And I'm going to hit my second point. Once I get both points highlighted like this, I hit set work offset and I put a value in there. And like I said before, we're in the perfect environment here. We did not see a change. Okay. So now once we hit our line of edge, now we need to set our X and Y. We set Z, we set our coordinate rotation so that we're square to the part. If we had that off a little bit in our fixture, again, we're in the perfect environment. We're square to this machine. So I can come up in Z, right? And I can come up in Y and X and get it relatively, again, somewhat in the center of my part. And once again, because I hit that Z, I know how high I am here. So I can quickly come here and position, let's say 5 millimeters above the part. So I hit cycle start here. Now I'm 5 millimeters apart above the part. I can go back into measure workpiece and go into picking a rectangle. So I can measure rectangle spigot. I'm going to measure work offset G57, and I'm going to go down 15 millimeters. So here, I'm going to go past the stylus again, hit cycle start, and I'm going to be able to pick up my part. So now my workpiece is set. So I'm ready to go and actually hit cycle start on my program. The key here is if we were going to move this part over a little bit, or move it back a little bit, or move it to the side a little bit, this would work. This part would work on this setup. And the key to that is a couple things that we use as far as Cycle 800 as well as Traori. We're always going to be tracking where this part is on this table. Now the key to this is, the only caveat when I say that is, as long as you have long enough tooling, it really makes it the key here. So if you're ever going to be off the table or off the center of the table, it really comes down to making sure that your gauge line of your tools are long enough to reach when it swings around to go to the other side of the table. Because if you're off to one side, you're going to be farther away when you go and tilt the part down at 90. So if we look at this program, we're going to come in the program manager now, and I've set up two basic programs, one to handle all the pockets and rough out all the pockets on all 5 sides, and then to do a 5-axis Traori move on the top of the part. So with that being said, I'm going to go right into here. I was playing around with some work offsets earlier, so I'll comment that out, and I will hit execute. So here, all I need to do is hit cycle start, and she's going to go grab the tool and start to machine all 5 sides of my part. Once she's done with roughing out all the 5 sides, we'll see her going to a full 5-axis motion, because we wanted to kind of give you kind of an understanding that this is also 3+2 as well as full 5-axis. So the key here is we have a nice gauge line tool that reaches the part and also gives us enough reach to do a full 5-axis. So here's a full 5-axis motion. We're moving around and just doing a swerve pattern on the top of the part. So this is a simple setup and a simple 3+2 plus 5-axis setup. And the key here is, and the nice thing about this kind of setup of having like one fixture and one part that you're doing on a 5-axis machine with Sinumeric, is the key here is setup is quicker, and that's really the name of the game. And then there's so much more that you can do with setup of parts that gives you the ability to set this up faster with in-process probing, to set your work offset, to in-process measuring to make sure that your parts are coming out good. This really makes everything really nice and easy and compact. So again, once you have all this information set up from the beginning using the probe, makes everything really, really easy. To jump back into the presentation, we're going to go into the advanced work holding and tooling. So this is something that I have been working on for quite some time now. I worked on a project where I came up with the fixture that you see on the left and the fixture that we're going to use in this webinar. And with that, the left one basically is setting the parts and getting more parts on the table that you potentially can. Same thing with the right. You're getting more parts on it and taking the advantage of getting multiple angles inside the machine, because most of, like I said before, most of the machining is 3+2. So as long as you can get them set up and do it relatively quickly and then know where your offsets are coming, really, really helps you kind of get through this. So with a multi-sided vise, you get more parts and more finished parts per opened door. So you're yielding more finished goods per open door, and then you're reducing the overall tack time of the part. So tack time is what you would say is the overall part to the customer. So that's setup, that's programming, that's setup on the machine, that's all that put into one part. So now you're going to reduce setup, and you're going to reduce tool changes, you're going to reduce the time that it takes to make a good part, because you're going to get more off when at every door open. And then with the dovetail, you're able to have a smaller, even smaller clamping with more clearances and more sided. So now you have the ability to even put more parts on the table when you take advantage of the dovetail. So we'll see the pyramid and how to set that up on the Sinumerik Control when we do the live one.
Hey, Dan, did you accidentally mute yourself?
Yeah, that was weird.
I'm sitting here thinking, I bet you he's just talking away to himself.
I am. I am. I am. So let's go back a page, because I don't think everyone heard that.
We got this. We lost you when you transitioned to the tooling.
Okay, perfect. So we heard everything on pyramids, right?
Yes, sir.
Okay, perfect. So we'll go to the tooling now. So when we get to advanced work holding, we're going to need some advanced tooling. And when I mean the advanced tooling, I mean tool holders. So the thing and the key to understand here is there's some things that usually kind of go hand in hand. We hear 5-axis, we think shrink fit. We hear 5-axis, we think of small collet holders or hydraulic holders. These are some of the things that we hear when we talk about 5-axis. And the reason and the name of the game is really this small nose diameter. It's really kind of the key here is that we have this really small nose diameter. The reason being is usually when we kind of take the part away from the center of the table, now we have a lot more angles that we need to prepare for and a lot less clearances. So we need the small nose of the tool holder to kind of get us closer to the part. And really, even in a simple 5-axis setup to the advanced 5-axis setup, we really want to get that part and that tool, the tool holder and the tool, as close as we possibly can. So the shortest that we can make the tool holder assembly is the key. So that is the key right off the bat. However, when we get to these more advanced kind of setups, what we end up seeing is we need longer tools or longer reaches. And with that, we have things like in the top right corner of this slide, we have a lot of different setups. So we have a shrink fit into a shrink fit into a shrink fit into a tool that's shrunk into that tool. So this is some of the typical setups that you might see in some of them, that you get into these high advanced setups that you're going to need this kind of reach, right? We're going to need to reach a feature or reach a tool or reach that. I've seen it to where even a probe is kind of assembled that way to reach a feature to probe it. So this is some of those things when you start to get into the advanced setup of a 5-axis part. You're going to really want to think about your nose diameter and then the gauge line of your tool and how we can reach that, especially when you're looking at like a pyramid or you're taking your part and you're angling it off. So that's really kind of key. So to show you this 5-axis setup advanced, we're going to actually take it to you on the same machine. So one of the things that we need to do is we need to think about when we tilt the machine down and we look at our fixture. When we actually put a pyramid on this machine and we tilt it down, that we're going to need a longer tool. This tool is not going to it's not going to be able to get there. So we can kind of show you that when we start to rotate through. So once again, we're going to need to get some tooling as well as our fixture. We're going to start with the fixture and we're going to see if this tool works. We're going to kind of see if this works. And if it doesn't, we're going to then kind of see how we need to take advantage of that longer tool or that longer gauge line, right? So with that being said, I'm going to come into, again, minimize and setup. And all I need to do to get rid of this setup is I'm going to get rid of it, right? And I'm going to go into my library again, and I'm going to create a new setup, just like I did before. I'm going to then now import my STLs. right? And here I have 3 work pieces set up for my pyramid, as well as my pyramid that I have set up here. So this is my pyramid with 3 different work pieces, and now I can set this up and put this on the machine. So once I set that up, I can come back to my machine and go to setup, and I have now my pyramid on my table. Okay, I can go now back to machine, and we see our pyramid. So this now becomes kind of one of those advanced setups. And really what we would do back in the day on something like this is now we have to get out our indicator. We would probably either clamp on something in this position that we knew that was ground flat, get out our indicator and rotate it to a position that was somewhere in that area, and then set that as our work offset. For the purposes of Sinumeric, and what we have is a really kind of cool function is called align plane. So if we go to machine jog and we go back, we have this button called align plane, right? So when we align the plane, now if we come and hit 3 points on this top of this part, we're actually going to align this surface to the spindle, and it makes setup of this part really easy. The nice thing about this is we're not going to no longer look at the physical machine anymore. We're going to look at the coordinates. And what that means is your X, Y, Z, your coordinate that you would put on your work coordinate system that you put in your CAM system would be matching what you're putting on your work part. And so we're actually going to set that coordinate system and make it normal to the spindle. So that's what we're doing when we set this. So when we come into 3-point alignment, or align plane with 3 points, notice there is no set for physical setting our C and our B here. This is going to set rotations around our axis, our coordinate. So one thing right way that the system noticed is we don't have a probe in our spindle. We have an end mill. So we could totally use an end mill to do this. So this is kind of the cool thing about our cycles. We can either use a cal tool, or we can use an end mill. As long as we have something in the spindle, we'll see that kind of getting recognized as we see the animation. So now if I go and tool change into a probe, you'll see a probe in that field, and you'll start to walk around the aligned plane. So we cycle in our TSM page, go to tool change. Now we got our probe in there. If we went back to now measure workpiece, we will see a probe now in there. So this is kind of knowing that you got the probe in the spindle, and now all we have to do is make sure that we have the right work offset. So we have G54, and we're going to now set our rotations. One of the things is just make sure that everything's kind of, there's nothing active as far as cycle 800 goes, but we're just going to make sure that our table 000, as well as everything's ready to go to start to hit 2 points. So basically lock our pyramid down, put our vices on our pyramid, put our workpiece in there, grab our probe, and now we'll hit 3 points. Once we hit 3 points, I'll use something called swivel cycle to make it normal to the top and normal to the surface of the spindle. So the surface of the workpiece, normal to the spindle. So I'll move my probe over my first part. And I'm just using the jog command to do this. I'm just going to jog over to my part, and I'm going to get somewhat over my part. Once I get close, let's see here, I'm getting closer. Now I can do my 3-point alignment. So I come in here, and just all I have to do now is hit cycle start. And I took my first point. And then I'm going to move down in Y, come down in Z, and hit cycle start. And then come over in X and hit cycle start. So I just do 3 points. And now once I hit set work offset, right, I say okay. And now what I've done is I've put 3 points into my work offset for G54. And now I can come into swivel cycle and hit cycle start. And what this does is now I'm going to actually set that coordinate system in that part for that workpiece on that pyramid square normal to the spindle. So now I'll use this cycle, and this is what basically cycle 800 is. But this is now the ability to set our part square. So now our part is square, and now we can set it to our XYZ now. But the key here is there's something interesting that when you do this, right? And the interesting thing is basically like we just rotated the part. It may seem like we rotated, but actually we rotated the coordinate system. So the key here is to understand where your XYZ is. If you don't care where your XYZ is and you're just going to tell your CAM system this is where XYZ is, that is fine. And more times out of 10, I kind of fall into that realm. I don't really care where my work offset is, that it doesn't track the same as the machine, but most operators want to see X go X and Y go Y and Y negative go Y negative and Y X negative go X negative. So the key here is right off the bat is to start to jog your axis. So if anyone sees that I jog this axis, right? And if we pay attention really closely up here, that my y-axis is actually moving because we're 90 degrees out. So now we're 90 degrees out. Because we're 90 degrees out, we need to tell the control that the coordinate system is 90 degrees out. This is a really, really easy way and quick way to do this because we're going to use that aligned plane. An aligned plane is going to rotate your coordinate system. So here we can tell it when we come into 2 points on this part to align that edge, align our coordinate system, we can tell it, hey, you're 90 degrees out. And when we tell it that they're 90 degrees out, now X will be X positive and Y would be Y positive will be Y positive. So this will make things really nice when you go to set this machine up for each one of these stations that when you go to your CAM system, it's literally going to be the exact same thing. So that makes life a lot easier. So here we're going to go back to measure workpiece, do 2-point alignment, and we're going to use this to set up our work coordinate system. But in here it has a special angle, right? And this special angle is we're going to tell it that we want our coordinate system to be 90 degrees rotated. And when it does that, it actually knows the order of operation in the rotations underneath our work offset to actually calculate where that is. So the nice thing here is this does all the math for us. We don't have to figure out that we need to rotate Z this and then rotate X this or whatever it needs to be as far as the order of operation goes for our work offset. We don't have to think about that. This probing cycle is going to do it for us. So again, once again, I'm going to bring it over to the part and touch 2 points, and it's going to realign our coordinate system to make X be X and Y be Y. So this will be really nice and easy. I really like this feature. If anyone's been following Mr. CNC, we've done this more than once on some 5-axis machine demos where we've used the pyramid to kind of really kind of stress that our probing really kind of helps you set up your part. So we'll come over in X. Now the next is Y. A little far away in Y. And we'll come down in Z. We'll do that 2-touch, right? So again, like I said, here, make sure that we're close enough. And all we need to do here is hit cycle start. But the interesting thing is when we see this, right? If we see this, get a better angle. That's better. So now if I hit cycle start, right? I did a Y plus, right? And it didn't touch the part because Y plus is 90 degrees out. So here we need to use actually X plus, and we're going to be able to set this 90 degrees from it. So I hit reset, cycle start, sets our first point, come over in X and hit our second point. And now I hit set work offset. If I come back to this and I hit cycle start, right? And now I move X, we'll see that X now is moving in the positive direction and Y is moving in the Y minus direction. So we are now set, okay? And now we have to hit ZXY and we'll set the top of our part, right? So here, what we'll do is we will move over and position to the top of our part. And we'll come down on Z, go over in Y, and again, we'll follow that same procedure, Z, and then we'll do our X and Y. So we'll get close. Oh, too far. Come down in Z, and we'll hit measure workpiece, Z, cycle start. Now we set our Z, right? C is good. And then now we're going to set our X, Y, and Z. So we look like we're good in X, a little bit off in Y. And we go back to measure workpiece. We're going to do this rectangle spigot, hit cycle start. Now we're going to set our X, Y, and Z. As you can see, we're moving around and setting our X, Y, and Z. Now we set that up. We're good to go. Now we're set to start to utilize this to set all the other positions. So once that's done, you can go ahead and do this again for all the other, repeat the process for the other stations, and now you have each one of them set up. So if I go into my work offset, we go to G54 and details, you can see that there is our rotation under the coordinate system, right? And that is what's going to set this center to that. So now if we go and run our program, right, for each one of these stations, we are going to now, I'm going to change this tool, right? And I'm going to make this the end mill, right? Just the BR32. Okay, we already have that tool in here, and this is where it kind of comes into kind of using some advanced tooling, right? And so now if I hit cycle start on this, we're going to go in and we're going to do that first tool, and we could probably do the first machining fine. The second one, again, fine. But once we rotate down to the side, this looks good. But once we go through the center of the fixture, this is where it's going to get pretty scary. Right here, right? So we ran out of travel before we actually crashed. But if we, if we had the travel, we probably would get way too close to these other fixtures. So this is where we need to start thinking about different kinds of tooling. So here I actually have I have a longer tool, and that longer tool has a smaller nose, and this is a small collet tool that I've used from a Mugi that kind of is kind of a high gripping tool to kind of give me that length to go through that. So one of the things too is that the nut of the tool is a lot smaller, and the tool kind of tapers down to get away from these vices. So if I wanted to machine farther away, I could totally get that. Also, too, in this setup is that I'm going to be away from these vices too, because the nut is a lot smaller on this tool holder. So this is kind of the key when you start rotating down. So we have a smaller nose to the tool, which gets us away from the jaw vices of the vise, as well as gives us clearance because of the length, and because it tapers down, we're going to get away from these other work pieces. So once again, we got to build that tool up. So we need to get that tool into the 3D environment, and we need to first tell it on the control side. So we'll go back to tool offset, and we'll come down here and we'll say new tool. It's going to be an end mill, right? And we're going to now say it's going to be a 12 millimeter underscore longer, right? And here, I know off the top of my head what the gauge line was for my cam system was 230 millimeters, my cam system, and it's a 12 millimeter again, so I'm going to say 6. So once I say I have it in my outside my magazine, I got to load it in the machine. Once I load it in the machine, she goes into the case. She's now into here, and I'm going to go back to the 3D environment and bring in my step. So once I bring in my step, I'm going to go to minimize tool, and I'm going to define that longer tool. So I'm going to find 12 millimeter longer, go to detail protection, and then here I have this import tool assembly, and I have a 12 millimeter long, right? Open that up, and now I get my 12 millimeter longer. And so if you guys notice here, I have a nice taper to that. And then my nose of my tool holder is a lot smaller, which gives us ability to really kind of get closer to the part. If anything, I can even shorten up my tool in my collet if I had a smaller gauge line. Okay. So again, I'm going to pick my holder first. This is my collet and my holder. I'm going to say this is my holder. That's one. And then once I pick that, I'm going to pick my end mill, and I'm going to import that in, and there's my tool. So again, now I have my tool in there, and once again, like I said, we have that smaller nose, which gets us the ability to shorten up my tool, and I have now the gauge line to to reach my part. So that's what I'm definitely going to take. Another thing that I didn't mention in the tool holders, but we definitely want to go over it, is one of the things when we look at this tool holder page, there's quite a different types of tool holders here. So the different types of shrink and hydraulic and small collets, but as well as the different holder types. So there's Cat 40 on the screen, there's Big Plus, there's also HSK 63 that you see on the page. And so there's a big difference here. There's kind of some distinction between it. So Cat 40 has been predominantly what's been used, and that has a taper. And there is some downfalls to that. One of the downfalls is as you start to turn a Cat 40 spindle at high RPMs, you get bell mounting. And what ends up happening is the tool actually kind of gets pulled up into the spindle. This really kind of hinders flatness on your parts, right? And so then there became some other type of tool spindles, which is called HSK, and the difference is the way that an HSK is clamped on the inside of the tool. So as you spin in high RPMs, the tool clamping force goes and pulls the tool actually on the tool on the outside of the tool. So this gives us the ability to having more clamping, as well as there's face contact. So it's really kind of sturdy, gives you the ability to do a lot of side loading on your tools, as well as a slide roughing, face mill contacting too as well. So that's really kind of the benefit of that. As well as we talk about advanced setups, this is what you really want to kind of gear toward your tooling towards, is going towards HSK. It really gives you the ability to push your tools and give you kind of some some unique ways of utilizing different types of tool holders. So back to the setup. We got our tool on the spindle. We're ready to touch it off again. So we can definitely do that. So we can say save changes, and I want to touch my tool off. I got to get my machine to have the tool touch come back on. So we got to see our tool touch is right there, right? So we need to now call our tool up and touch it off. So we got our work offset set. Now we got to get our tool offset set. So this is really kind of easier. We come to machine and jog, TSM, and then select our tool longer, right? So here's our 12 millimeter longer. Say okay to that, hit cycle start. And now the tool is going to come in the spindle. Once the tool is in the spindle, we can come to tool, length auto, hit cycle start, and she's going to go over and measure that tool. Tooltip has been modified. I guess I might be out of the range of the tooltip here. Nope, there we go. So once we hit it, as we can see, a little bit of discrepancy, not by much, 18 microns from what is in the real world to the cam environment. Now that I have my tool touched off, I can get rid of that cover, and now I can see my part a little bit more. So now I can go and restart my program. Once I restart my program, I'm going to change my tool. I made a little bit of a variable here to change my tool. And once I hit execute, now I'm going to go through all the stations of this part. So we have our first roughing, and I will go through the second roughing. And then we'll do the 5-axis toolpath. Oh, nope. That'll come after it. Sorry. So now we're going to the next one. I already did that work offset on the next one. And we'll start to machine those and then rotate around and do the other ones. Once it's done, we will start to go through the full 5-axis. So I'm actually did a little quick macro to index my work offset for each one of these and then run it per tool. So again, doing this, the key here is if I had 2 different tools, one tool to do all the roughing and then one tool to do all the finishing, the key here is, as you notice, that I don't do tool change, do one part, then do the second part, finish. I do it all with one tool, and I do all the operations with that one tool on all the different fixtures, as well as then the next tool path or the next tool that comes out, then it does all that tool. So the key is we're saving on tool changes per part, and we're saving on less positions per part, so that we're just finishing per tool, and this really kind of reduces it. Some customers have been able to reduce, minutes, sometimes hours off parts because they just reduce the cycle, the tool change time. So now we're into the full 5-axis path, and you got to see now, because we're not in the center of the table, you got to see a lot more motion with full 5-axis. So there was G54. Now this is G55, and you start to see more motion here with being off the center of the table. And then the last one that we'll do is full 5. So here, just didn't want to show you that we can just do 3 + 2 when you're off the center of the table. We can actually do full 5-axis and machine our part. So here, we definitely can do it. And notice that, we're tracking and machining on each one of them. If I wanted to reset here, we totally can. But now as I start to work down this part, they're really finished. There's my taper on the top of the part and all my 5 sides on all 3 parts on all stations. Cool. So back to the presentation. We're coming to an end here. We talked about simple setup. We talked about an advanced setup, right? So here in our advanced setup, we had our part with our full 5-axis. We used 2 different things that really kind of line our part that's not on the center of the table and off on some angle. We used 3-point align plane as well as 2-point align edge, and that gave us an ability to start to line our parts up in every station. That is the 5-axis mastering 5-axis setup with Sinumerik. Now we can take some questions in the webinar.
Well, good job. I tell you, there is a lot going on there. So it's amazing to me when you look at those kind of setups, how quickly a very large machine becomes a very small machine once you start to stack those kind of work holdings on it and parts and extend your lengths out. So certainly a good point you said real early on that I truly appreciate, which is you need to make sure you fit the machine to the part and the application for sure. I think that demonstrates it nicely. Okay, so good job, Dan. We're going to open up to some questions. So on the top right corner of your screen, there should be a question field there. Ask a question to the speaker. You can put it in there or you can put it in the chat. I do see we've gotten some in the chat, so I'll start with the chat first, and then I'll transition over to the questions area. So there was a question, Dan. Gauge line same for CAT or BT?
No, they're going to be different. So that's the key there. Is the gauge line is going to be different, and the gauge line for CAT per machine is going to be different. So this is one of those things when you start to set up a CAT machine, and to get that positive tool length on the very setup of your machine, it's kind of crucial that you have a known tool length to set your CAT 40 or BT up spindle. So that's really kind of one of those big things. And what I mean by a known tool length is there are things that you can buy either from Renishaw or from Lindex or from Heimer, some of these tooling companies that have something called a test bar or a reference tool, and that reference tool has a known length that they've ground in it. Like that tool is perfectly 125 millimeters or perfectly 4 inches gauge line, and that gives an ability to know what your gauge is on your machine and kind of set it up. So everything gets set up off that reference tool, whether it be CAT or BT.
You think the gauge line is different though between CAT and BT? I mean, you can't tool change obviously a BT into a CAT machine or vice versa, but if I had a BT standard that I was using, I would expect that gauge line number on the standard to be the same because it's off the taper.
Yeah, I would have to look at that.
Yeah, I think that would need further digging because that's a good question. I'm not even 100% sure. I would have expected they're the same from a gauge line because effectively it's the same taper, but I would dig into that sooner. But for sure, you can't swap CAT and BT in the same machine. But in theory, I think you could use a standard because, keep in mind, as long as you have the right retention knob, I can manually tool change a BT into a CAT or vice versa, and the spindle will take it. Might be the same.
Yeah, that'd be interesting. It'd be interesting to see.
But your point is probably the most the most important one here is when you are going to transition to this type of setup, don't be cheap about it. Buy yourself a standard. They're not that expensive, and it's going to go a long way to standardize everything. I see so often guys will say, "Nah, I'll just work off the spindle face and not true gauge line." Will the machine run? Sure, but you're losing a lot of this potential. You can't go to an external presetter. You can't potentially move a tool geometry from one machine to another. So there's a lot of stuff there. I'd say spend the money, get the right equipment, do it right the first time. Okay. There was a question about the video, and I did put it in the chat, but yes, everything's recorded. You'll get an automatic reply from the system where you can stream the event on this webinar platform. But then we will take this video and it's going to go onto our Mr. CNC YouTube channel. So keep an eye there. Let me jump over to the other questions. The virtual sim, an option. Do you know if the DVF 5000 machine will come with the virtual sim? So I guess I'll take that one, Dan, since I've been working with Dan a little bit closer. So the simulation package Dan was showing you, which is my virtual machine. We have two variants, create or run. For the end user, it would be run my virtual machine. That will be available for the DVF 5000. Obviously, you can see the DVF here. Dan will turn on all the sheet metal. As far as whether it comes with it or not, I don't know for sure. I think DN is starting to still work out the details of how they want to deliver it. My guess is probably you'll buy the software from us, because keep in mind the software is independent from the machine OEM, and then you'll get the specific virtual machine file that is what Dan's running here that plugs into this software for the DVF. But keep in mind, this software, once you have it, you can support anybody's machine as long as you have this virtual environment file, which we call a VCP file. Okay. So a couple other, Dan. So will the cycles work with my Marpos probe?
Will the cycles work with your Marpos probe?
Yeah, I'm assuming they're talking about the probing cycles you were showing.
Yeah, so the manufacturer then would create the cycles using the Marpos probe. So you would calibrate your Marpos probe for your machine that was commissioned on that machine tool with these cycles. So that's kind of the key coming from the builder.
But the cycles themselves are Siemens cycles, so they are universal, right? So they will work with anybody's probes. Correct?
Yeah.
Yeah.
Correct. Yeah. So the cycles that we have here underneath measure workpiece that we talked about today, these are standard for Siemens. When you have a Sinumerik Control, it's up to the builder if they put a Heidenhain probe on there, or a Bloom probe on there, or whatever type of probe they might put on there as far as what they put into the spindle. So that might be what they would use, even Marpos too as well.
But they'll all work with those cycles you're saying.
Yep.
Good. Can I use positive tool lengths on my Fryer 3-axis mill?
Yes. The answer is yes. You can.
I would absolutely agree. There is no limitation to the technology if you want to apply a positive tool length process. It'll work on the simplest machines to the most advanced. For the 3-axis vise setup, did you need to model the setup in CAM?
Yes.
You did?
Yes, because if we look at that setup, I put them all together. So it all depends. I guess to the question is
I think they're more thinking about the actual running of the program. So where all three vices the CAM system had to know where those vices were located around its own virtual global zero.
No. I think if you brought them in, they don't have to be in the same setup. So like if you just made, you had your CAM and you had no fixture inside your CAM, you didn't have to have your fixtures inside your CAM to then bring it over here. The answer to the question that I said, yes, you need to bring them in, is the meaning that just you have to make sure that they're all together. So I brought 3 different components, and those 3 different components I had to stack up my fixture. So I at least brought them into my CAM to make sure.
You're saying for just the virtual environment. I got you.
Yes.
I got you. That makes sense. All right, so we got a few more came in. Can virtual sim be run on the machine control itself instead of the desktop version, or is this webinar specifically for the desktop option? You want me to take that one?
I can take that.
Sure.
So for the machine tool itself, to have something kind of like this kind of virtual environment and this collision detection is an option that we kind of talk in the advanced collision avoidance. Something that we have on the machine is two different things. We have on this machine actually has collision avoidance, but it has the lesser package collision avoidance. And what that is it actually has some 3D components of the machine to actually do collision avoidance. When you're on the machine, you have everything that you'll see on the left side of the screen. So you'll see the buttons. All these buttons will be the MPC panel, MCP panel, and then as well as the screen for us will look like this. And for the machine and collision avoidance is you actually have in here the model of the machine and some components. And this is the lesser one because really we just need to know the table diameter, and the table bottom is not going to collide with the spindle, right? So this is not going to collide it. And this is kind of one of those nice features that is an option for all machine tools that you could potentially have, is this something called collision avoidance. And what's nice is when you're going and you're machining, and let's say you're having coolant on there, right? If we go into auto, we have this thing called simulate record. And what ends up happening is we can actually see our machine space inside there when we start to run our program. Now, if I wanted to get really kind of fancy, I could also put my fixture in here and have this on the machine. So this is kind of the very first step to collision avoidance. And as we go, we get even more detailed as we go into higher levels of protect my machine. I think, is that what we're calling it now, Chris? Protect my
Yeah,
machine?
protect my machine. Yeah, and I think where there might be some confusion here as well. So everything we did is how you would do it on the actual machine. So we're using this digital twin just to give you an environment, but effectively pretend that the model on the right isn't the digital twin, it's the real machine. So the steps that Dan was showing are specifically what you will do on the real machine to align up this setup. We're just using the digital twin environment as a simpler way to get in front of a machine tool versus having to have a camera on a machine when we do this event. So don't let that confuse you. All right. Let's keep on going. Oh, I got to start. Can the version virtual? I answered that one. I think I answered this one. Okay. How the CAM software would work with virtual machine would be posts dedicated for virtual machine. So this software you're seeing is a standalone piece of software. So it doesn't have to integrate into CAM. Certainly you will use it as Dan did. He programmed in CAM in a CAM environment. So this would be part of your workflow. But what you would do is you would take your posted files. If you do have models that you drew up in the CAM system, you'll bring it in here. But this is a standalone package. It does not have to. So effectively, you can use any CAM system and drop the programs into this environment and then prove them out. Is there any PLC program required for the virtual machine? So this virtual machine is running a full machine environment with the actual OEM's PLC. So what happens is this virtual machine will be provided, in this case, by DN Solutions. Maybe it's another OEM like DMG or Track or any number of OEMs that are working with our controls can produce a full environment for their specific machine. Now, we do also have template machines if you buy the software. So if you're looking for something a little more universal that are non-OEM specific. Okay. Boom. And I think we are good. So Brandon also asked if we'd shoot him an email. So I will certainly send you an email so you have our contact information. So Dan, I think I got everyone. I'm bouncing back between the two different things. Oh, send me the pyramid fixture file. Sure. And that was, go back to the question. That was Brandon. Okay. So with that being said, I want to thank everybody for joining us today. And thank you, Dan, for a great webinar. I think there was certainly a lot of techniques here that will be helpful for those in the field setting up 5-axis. Certainly keep an eye out for more events like this coming your way, as well as a lot of other material from our group as we start to increase the frequency. And with that being said, again, thank you, Dan, and thank you, everyone. And we look forward to seeing you real soon. Have a great day,
Thank
everybody.
you.
All right. Goodbye.